So here's some more examples of graphing parabolas and all the things we can answer about parabolas, just given the quadratic equation that describes their motion or their actual behavior, I should say. So first of all, this is a first example here, and this is f of x equals, and I wrote it down over here, so it's a little bit bigger. 1/4 x squared minus 5/2 x plus 13 over 4. And right away, if we look at this, we're going to answer these questions. Right away, we can see that if we put 0 in for x, we'll get the y-intercept, which is 13/4. So we can note that down. That's going to be the y-intercept. That's easy. Just put 0 in for x. When x is 0, this is the y-intercept. So we can see that right away. And we want to put this in vertex form. So in vertex form, we're going to kind of complete the square process, and we really don't want anything in front of the x squared, so we're going to just temporarily move these denominators over to the left side by multiplying both sides of this equation by 4. So if I multiply the left by 4, I've got 4 times f of x. If I multiply 4 times 1/4, I get just x squared. If I multiply 4 times negative 5/2, 2 goes into 4 twice. So I have negative 10x. And if I multiply 4 times 13/4, I have plus 13. So we just move the 4 over here temporarily so we can complete the square process and find our vertex, or put this in vertex form. So now I've got 4f of x over still. And that equals x squared minus 10x, and I'm going to move the 13 over here to the right. Now some people put the 13 on the left and then do it and then move it back, and that's fine. This is just the way I do it. Okay, then we'll complete the square process. Square root of x squared is x. What's half of 10? 5. And what I'm going to add is 5 squared, so I'm going to add 25. Now since I'm working on the same side of the equation, if I add 25, I've got to subtract 25, so in essence I'm just adding 0, so I'll subtract 25. And now I know that this is a binomial square here. This is a perfect square trinomial, so it's going to factor to be a binomial square. This sign goes here. This is going to be x and 5. And 13 minus 25 is negative 12. So minus 12. And I'm almost in vertex form, except I've still got the 4 over here. So don't forget, you still got this 4 hanging out that we kind of moved. So we can do our housework over here on the right and then put it back. So now we'll divide everything by 4. I can divide that by 4 or multiply by 1/4, so I'm going to do that. And then if I divide 12 by 4, I'm going to get negative 3. Hope you can follow that. I didn't write all these steps down, but by now we should be comfortable with that. And now we can tell our vertex. Our vertex is going to be 5, negative 3. So there's your vertex. So we can start to graph it. Next thing we'll want to find is the x-intercepts. That's going to help us graph it, and the y-intercept. So let's put some of these things down. So let's put the vertex down at 5, negative 3. Now, remember, since this is positive, is this shaped like a U or an N? It's shaped like a U. So we know this. This means we're going to have a relative, or we're going to have a minimum, I should say. All right, we also have intercepts. 13/4, which is the same thing. 13/4 is the same thing as 3 times 4 is 12 and 1/4. So that's maybe around over here. Now let's see if we can find the x-intercepts. So that's the y-intercept. We already found the y-intercept was, and I'd just like to put the point down 0, 13 over 4. This is actually the intercept 13/4. But I like to put the point down. Now the vertex we just found, that's going to be 5, -3. And it opens up because it's shaped like a U, so we can answer a lot of these questions. Opens up. And the vertex form, we already have this now. That's going to be 1/4 x minus 5 squared and minus 3. Okay, so we got all this stuff. Oh, sorry, there you go. Now the x-intercepts, that's going to be where it crosses the x-axis, and notice that when it crosses the x-axis, the y is 0. And the y and f of x, they basically the same thing. Y is just represents, sometimes we say y equals f of x. So these are the same thing, it's just a function. So in this way, it's the coordinate form, y. So what we can say is just y equals 0, so we can just set this equal to 0. Now there's a couple ways to do this, but since we already have it in vertex form, it's pretty easy to solve it for 0, so we'll just call this y, and you can see this. So we'll say 1/4 x minus 5 squared minus 3 equals f of x, or we'll just set that equal to 0. So we want to know when the vertical position is equal to 0. That's going to give us our x-intercepts. What I can do is I can add 3 to both sides, so I can have 1/4 x minus 5 squared equals 3. And I can multiply both sides by 4 to get rid of the fraction, so I've got x minus 5 squared equals 12. 4 times 3 is 12. And then I can write that x minus 5 equals plus or minus the square root of 12. That's almost a definition. If something squared equals 12, then that something equals plus or minus the square root of 12, and then I can add 5 to both sides, so x equals 5 plus or minus the square root of 12. Now, I got a little calculator over here from the 99-cent store because we're going to want to find the values so we can graph it. And we've talked about approximating before in my class, but if we have a scientific calculator, or just one that takes square roots, it's not too hard. So let's find these two values. So we've got either x equals 5 plus the square root of 12, or x equals 5 minus the square root of 12. So I'll turn my little calculator on here. It cost me all of 99 cents. I got it a couple years ago, still works. So we want 5 plus the square root of 12, so I'll write 5, or put in 5, if I turn it on, of course, 5. Now this works a little different, so I have to put plus. There it is. And then I'll put 12. And then I have to put square root. So that's the square root of 12. And then if I want to add those, then I write equal. So that's the square root of 12. So 5 plus 3.46 should be about 8.46. And then if I press equal, it does that. See, so it's pretty nifty. So that's going to be 46. And now I want 5 minus the square root of 12. So again, my 99-cent investment will pay off. I'll clear that. And I'll write 5. And I put minus, or enter 5, minus. And then I'll put 12 again. And I hit square root, so that takes the square root of 12. And 5 minus is 3.14 should be 3.46 should be something like 1.4. And when I get that, I get 1.53, something like that. So that works. So x equals 1.5 if I round it up, since that's 5 greater, that's 1.54. So those are your intercepts. So we want to write those down. And those are actually points. Now it'd be kind of hard to fit that in if I write the zeros, but that's what it is. So the x-intercepts are R 1.54 and 8.46. And I like to write that the point is going to be 1.54 comma 0 and 8.460. So those are the intercepts, and I can put those in And let's see, this is going to be at 8.46, so there's 8, so about 8.5, and then 1.54. And that looks pretty good. And my axis of symmetry, that's going to be down here. It's going to be the line that goes right down the middle, or actually the x value of the vertex, which is 5, so it's going to just be x equals 5. And I'll just draw that dashed line right down there so we can see our symmetry. And we know we have a point on the other side of the symmetrical line for the intercept. So I'm going 5 to the left, so I'll go 5 to the right. I'll just barely make it. And there's my symmetrical intercept, which is 3 and a 4, something like that. And I got 5 points, so I can pretty much get a pretty good graph. And there you go. So that's our parabola. What's the range? Well, the range is going, well, the domain is all the real numbers. So the domain is negative infinity to infinity. Now the range of the y values, and I do have a minimum value over here, so we have a relative minimum value. The minimum is negative 3, or we could say y equals negative 3. That's our minimum value. Our minimum value would be negative 3. All right. And the range would be all the values that are my y takes on. Now, it doesn't take on negative 4 because it doesn't exist down here, so it starts at negative 3, so the range is going to be including negative 3, and then it's going to go up and up and up, and these keep going. So sometimes we put arrows here to indicate that that's just going to keep going up and up and up, all the way to infinity. So it'll be negative 3 to infinity. And that's my range. And infinity is always open. So I think we've answered all of our questions there. Okay, so I hope that all makes sense. You can pause it and go back and look at it. And I did skip some of the algebraic steps because I thought those would be pretty easy for you to follow. You know, multiplying both sides, or dividing it by 4, dividing 12 by 4 to get 3. So I did skip a few steps just to save a little time. Okay? So I hope that will help you kind of understand all the properties we can get and identify from a parabola just by using that equation.